Nisar, the revolutionary satellite launch by ISRO and NASA. Prepare to witness a groundbreaking leap in Earth observation, one that could transform how we understand and respond to our planet's ever-shifting landscapes. Indian and American space scientists have joined forces to launch a trailblazing satellite that is set to monitor Earth's most subtle and dramatic transformations in real time. But here's where the debate heats up. Could this international collaboration change the way we foresee and manage natural disasters? Or does it raise questions about data sharing and technological reliance? On Wednesday, a new chapter in space history began as the India-US Nisar satellite, short for NASA-ISRO Synthetic Aperture Radar, soared skyward from the Satish Dhawan Space Center in southern India. This impressive 2,392-kilogram spacecraft won't just keep an eye on one region. It aims to scan the globe for tiny shifts in land, water, and the planet's frozen sheets, sending back vital information that can help every nation better prepare for catastrophes like earthquakes, floods, or wildfires. And this is where things get truly fascinating. Nisar will orbit in what's known as a sun-synchronous polar path. Translation: it will pass over the same spots across Earth at fixed intervals, capturing fresh images every 12 days. This repeated coverage means it's possible to detect anything from glacier melt in Greenland and Antarctica to land shifts caused by urban expansion or farming. As Mila Mitra, a former NASA scientist, explained, this cycle of high-resolution scans will allow ground teams at both NASA and ISRO to monitor, analyze, and predict everything from shifts in coastlines to the early warning signs of volcanic eruptions. These constant, precise updates matter because our planet's surface is in a state of perpetual flux, sometimes subtly, sometimes rapidly. Sometimes it's nature taking its course. Sometimes it's human activity leaving its mark. Karen St. Germain, NASA's Earth Sciences Director, captured it succinctly. With NASA, we'll spot warning signs of earthquakes, track land settling or bulging, record the disintegration of ice, and even watch how urban development changes the landscape. Here's a point bound to spark opinions. With such sophisticated surveillance, should there be concerns about privacy, technological dependence, or geopolitical rivalry over the control of such sensitive Earth data? What do you think? Before NASA starts its mission in full, the satellite will spend about 90 days unfolding its instruments and undergoing a series of rigorous checks. Only then will it begin transmitting its stream of crucial observations. This ambitious $1.5 billion project has been a decade in the making, and wouldn't be possible without India's launch vehicle, payload contributions, and top-tier space facilities. Another remarkable subplot is how the project took shape amid the global COVID-19 pandemic, with Indian and American scientists collaborating across continents, defying logistical and travel challenges. As NASA's Karen St. Germain highlighted, this effort stands as a testament to what global science can achieve, even against the odds. V. Narayanan, ISRO's current chairman, hailed Nisar as life-saving and a beacon of India's growing stature in the space world. He called the launch another proud milestone in the nation's stellar history, while Jitendra Singh, India's Minister for Science, described the mission as a hallmark of international teamwork, a scientific handshake reaching across continents. It's worth noting this collaborative breakthrough comes mere weeks after Indian astronaut Shubhanshu Shukla's voyage to the International Space Station, and on the heels of remarkable advances in India's own program, historic lunar and solar missions, and bold plans for launching humans into space, establishing a national space station by 2035, and aiming for a crewed moon landing by 2040. And this is the part most people miss. While the mission is hailed as a victory for India-US relations, it also prompts us to ask, could such partnerships set new international standards? Or will heightened cooperation spark competition and spark new rivalry in space? Now, we'd love to hear from you. Is Nisar the dawn of a new era in global disaster preparedness and scientific discovery? or does it raise new ethical and political concerns that we need to discuss? Share your views. Are you inspired, concerned, or skeptical about this international venture? Let's get the conversation started. US and India launch historic joint mission to track Earth's surface changes. A groundbreaking joint mission between the United States and India has launched a revolutionary satellite designed to track subtle changes on Earth's surface, potentially reshaping our understanding of the planet's dynamics. This mission, known as the NASA-ISRO Synthetic Aperture Radar (Nisar) mission, represents the first collaborative effort between the two nations to study Earth's changing landscape. The spacecraft, equipped with advanced radar technology, aims to monitor shifts in ice, land, and even the movement of tectonic plates, offering unprecedented insights into natural disasters and environmental changes. The Nisar satellite, roughly the size of a pickup truck, employs two types of synthetic aperture radar, L-band and S-band, to detect minute variations in Earth's surface. Unlike conventional radar, which uses radio waves to measure distances, Nisar's sophisticated data processing allows scientists to observe these changes at high resolution. The mission's launch, which took place from India's Satish Dhawan Space Center on Wednesday, was streamed live on NASA Plus and the agency's YouTube channel, highlighting its global significance. The satellite will orbit Earth 14 times daily, completing scans of nearly every inch of the planet's surface every 12 days. Its dual radar system, developed in partnership between NASA and ISRO, will track shifts in land masses, monitor landslides, and detect changes in glaciers and forests. By analyzing these movements, scientists hope to predict natural disasters like hurricanes, volcanic eruptions, and wildfires with greater accuracy. The data collected will also support climate research and disaster preparedness efforts. This mission, first proposed in 2014, marks a milestone in international collaboration. NASA and ISRO, both leading space agencies, have worked. The partnership, which began in response to the National Academy of Sciences 2007 Decadal Survey, underscores the growing importance of cross-border scientific cooperation. ISRO contributed calibration tools, data processing algorithms, and satellite components, while NASA provided radar reflectors and communication systems. The collaboration between the two nations is not just technical. It reflects a shared vision of global scientific advancement. As NASA's Karen St. Germain noted, the mission symbolizes how two democracies can unite to tackle global challenges. Nisar is more than a satellite, she said. It's a testament to what we can achieve when we work together. The satellite's ability to penetrate clouds and rain, and its capacity to monitor infrastructure like levees and dams, further highlights its potential to save lives and protect communities. The mission's success hinges on overcoming logistical hurdles, including the vast distance between launch sites and the challenges of coordinating teams across 13 time zones. Engineers and scientists spent months traveling between the United States and India, often through long flights and late-night calls, to ensure the satellite systems functioned flawlessly. ISRO's director, Wendy Edelstein, emphasized that the project required a level of trust and cooperation that borders on mutual respect. This joint effort is part of a broader trend of international collaboration in space exploration. While the Nisar mission is a standout example, it also raises questions about the balance of power in global scientific partnerships. Critics argue that such collaborations may prioritize geopolitical interests over purely scientific goals, while supporters see them as essential for addressing shared environmental challenges. As the satellite begins its journey, the world watches with anticipation, wondering how this partnership will shape the future of Earth observation and disaster resilience.